Alright, in this video we're going to talk about section 1.6, graphical transformations, and this will be the first of 2 days on graphical transformations. So there's going to be a bunch of different ways that we can transform graphs. So by transform we mean move them up, down, left, right. We can stretch or shrink either horizontally or vertically. Those are all the things that we're going to talk about in this video. So if we see y equals f of x minus c, and x minus c being in parentheses, this is going to be a translation to the right by c units. And then if we see f of x plus c again in parentheses, this is going to be a translation left by c units. And this is the one that kind of does the opposite of what we think it should, right? We see a minus sign here. We usually think that's going to go to the left, but when it's inside the parentheses, it's going to do the opposite. So inside x minus c is actually going to go right c units. For our vertical translations, if we have f of x and then plus c on the outside, this is a translation up by c units. And if we have a minus c on the outside of the parentheses, it's going to be down by c units. So up and down works the way we would expect it to. Left and right is the opposite of what we think it should be. So let's look at a real quick example of that. So describe how the graph of y equals f of x can be transformed to the graph of the given equation. So if we look, this right here is kind of like our f of x. So when we see this right here, well, we see an f of x and then minus 4. So we know that this is going to go down 4 units. And then again, we see here, and we're thinking f of x is absolute value of x, so this would be f of x plus 2. So this is going to go left 2 units. So again, inside the parentheses, or in this case, inside the absolute value, is going to be right or left, and since it's plus, it's going to be the opposite, so we're going to go to the left. So those are translations up, down, left, right. We can also talk about reflections. So if we have something like y equals negative f of x, that's going to be a reflection across the x-axis. And if we see y equals negative f of x, that's going to be a reflection across the y-axis. So we're either multiplying our function by a negative value or multiplying our x by a negative value. So find the equation of the reflection of f of x equals 5x minus 9 over x squared plus 3 across each axis. So the x-axis, if we look up here, the x-axis is the one where we have to multiply the function by negative 1. So negative f of x is going to be negative 1 times 5x minus 9 over x squared plus 3. So this is really negative 1 over 1, so we just have to distribute the negative 1 through the top, so we can get negative 5x plus 9 over x squared plus 3. And then if we want to go across the y-axis, that's going to be f of negative x. So we want to, anywhere we see an x, replace it with a negative x. So we get 5 times negative x minus 9 over negative x squared plus 3, simplify a little bit, negative 5x minus 9 over negative x squared is still just x squared plus 3. Alright, so that takes care of reflections. There's one more thing we're going to talk about, and that's going to be stretches and shrinks. Now these can work 2 different ways. So if we have y equals f of x divided by c, that's going to be a horizontal stretch of factor c if c is greater than 1. So if c is greater than 1, then we are going to have a horizontal stretch. So we're going to stretch left and right. It's going to be a horizontal shrink by a factor of c if c is less than 1. Now, if c is equal to 1, then we have f of x divided by 1, which is just f of x, so we're not really changing anything. So greater than or less than 1, not or equal to. Now, if we have c times f of x, this is going to be a vertical stretch by factor c, if c is greater than 1. And it's going to be a vertical shrink by factor of c, if c is less than 1. So, horizontal is going to be if we're dividing on the inside. Vertical is going to be if we're multiplying on the outside. So let's look at an example, and then we'll call it quits on the video. So find the equations to change y equals x cubed minus 16 to the following non-rigid transformations. So this is something that we didn't really define, but a non-rigid transformation are the ones that are going to change the shape of the graph. So if we were just translating right, left, up, down, that's not changing the shape of the graph, it's just changing the position of the graph. If we reflect over an axis, again, it's not changing the shape, it's just changing the orientation. If we're going to stretch or shrink, that's when we get our non-rigid transformations. That's when we're going to actually change the shape of the graph. So if we look at A, it says a vertical stretch of the function by a factor of 3. So if we look at the table we just saw, a vertical stretch is going to be of the form y equals c times f of x. And it's going to be a stretch if c is greater than 1, and c is indeed greater than 1. So we're looking at y equals 3 times f of x, which is 3 times x cubed minus 16. And you could technically stop there. You wouldn't have to distribute to be technically correct, but let's go ahead. It's not going to be that big of a deal. So 3x cubed minus 48 would be our vertical stretch of factor 3. And then for part B, we want a horizontal shrink of factor 1/2. So if we look back, a horizontal shrink is going to be y equals f of x over c. And we want a shrink, so c has to be greater or less than 1, c is less than 1. So in this case, we're looking at y equals f of x divided by 1/2, which is really f of 2x. So we just need to put a 2x wherever we see an x. So x cubed becomes 2x cubed minus 16. So that's going to be 8x cubed minus 16 is going to be our horizontal shrink of factor 1/2. So when we're raising this to the third power, don't forget we need to raise both the 2 and the x to the third power. So that's going to do it for this video. We'll see you in the next one.